Hi there, fellow mathematicians. This is Miss Backfish, and I am here to talk to you about the unit circle, just going from the very basics of what is the unit circle, why do we need it, what's it all about. So let's dive right in. When we think of an angle, sometimes we're talking about an angle in terms of what we call a rotational angle or an angle of rotation. And the idea there is that we have a side where we're starting, and we call that the initial side. And that the other side of the angle, we're trying to figure out how we would rotate to get there, or we're almost like we're taking another ray sitting right on top of the initial side and we're rotating it. And that's considered the terminal side. Terminal means end. So this is where we end. So this would be my angle of rotation, would be starting on my initial side and rotating to the terminal side. And let me see if I can get this resolution a little better. Okay, so most often when we're talking about rotational angles or angles of rotation, the initial side is doing exactly what we did here, what I did here. It is pointing to the right, pointing over in this direction. So that if we think of it in terms of on the coordinate plane, we think of the initial side as being along the positive x-axis. Here's the x-axis, and the initial side goes out in this direction, and then my terminal side can go anywhere else. And my angle that I'm interested in is between them, starting here and going to that. We're trying to figure out how many degrees that is, or if we're using radians, how many radians that is. And we're going to talk about that in a second. So how do angles of rotation turn into this thing we call the unit circle? Well, the unit circle is basically just a handy visual that helps us look at quite a few of the most common angles, like this one here that's marked. And remember, the initial side points out to the right. That's like where my 0 is. And I'm going 120 degrees. This is 120 degrees. And what we usually do is we write that right here beside the terminal side. Remember, this is called the terminal side. Okay, so that's a 120 degree angle. That's in the unit circle. And basically, the common angles that we look at with the unit circle are the ones that are based on two things we learned about in geometry. 30, 60, 90 triangles and 45, 45, 90 triangles. Okay? Because there are a lot of angles that are built off of increments of 30 degrees or 60 degrees or 45 degrees. So what's happening on the unit circle is it basically consists of angles where I can make a triangle with the x-axis that is one of those types of triangles. Like this would be a 30, 60, 90. So let's go ahead and examine that. Okay, so here we have an angle that is 30 degrees. Okay? And that's 30 degrees above the x-axis. Now there's something called a reference angle. A reference angle is basically the angle between your terminal side and the x-axis. So for instance here, this angle is 120 degrees, but its reference angle would be how far it is from the x-axis. Okay, so the x-axis in whatever quadrant you're in. So in this quadrant, the second quadrant, I would come see how far it is from this part of the x-axis. So here I have a 30-degree reference angle. There are other places I have a 30-degree reference angle. Right here, that's 30 degrees here. Right here, that's 30 degrees below the x-axis. And over here we have one that's 30 degrees below the x-axis as well. Okay, and if we look at the triangle, right triangle I can make with basically the horizontal and vertical components of this point, that's a 30, 60, 90 right triangle, or a 30, 60, 90 triangle. Okay, and all of these are. Now, why is it called the unit circle? Because the idea here is that my circle has a radius of 1 unit. That this from the center to the edge, anywhere here is 1 unit. So if I have a 30, 60, 90 triangle where the hypotenuse is 1, remember these rules from geometry, The hypotenuse is the shortest leg times 2. So what times 2 gives me 1? That would be 1/2. Okay, and the short leg times square root of 3 gives me the longer leg. So this would be 1/2 times square root of 3, or we could say square root of 3 over 2. So this particular triangle has a horizontal component of square root of 3 over 2 and a vertical component of 1/2. That means the coordinates of this point are square root of 3 over 2 and 1/2. And all of these places that have that same reference angle have the same numbers in their coordinates, just different signs. This is the first quadrant, so they're both positive. Over here, it's negative, then positive. Here, it's negative, negative. And over here, it's positive, negative. So those are all my 30-degree reference angles. Okay, so that partly completes my unit circle. Now let's look at the same triangle, still a 30, 60, 90 triangle, but this time turned up on its side from the standpoint of 60 degrees, being the angle right here at the center, at the origin. Okay? Okay, so now we're looking at an angle that has a 60 degree, or a triangle that has a 60-degree reference angle here. The terminal side is 60 degrees above the x-axis. And that goes with one over here, and down here, and down here. Easy way to find the ones that it goes with is to just continue that terminal side through the origin and keep going in the opposite direction. Or reflect it across the y-axis here. Any of these locations of the terminal side is a 60-degree reference angle, 60 degrees above or 60 degrees below the x-axis. So now, remember we have our 30, 60, 90 triangle. Let's think about what it looks like if it's up on its end like this. Same numbers. Here's my 30-degree angle. So this would be the 1/2 down here. This is my 60-degree angle, so here's the square root of 3 over 2. So this is 1/2 and then up square root of 3 over 2. So the coordinates of this point are 1/2 root 3 over 2. And this point would be negative 1/2 and then up root 3 over 2. That's right here. And this one would be left 1/2, which is negative 1/2, and down negative, negative. And over here, right 1/2 and down root 3 over 2. So positive 1/2 down root 3 over 2. Okay, so there are all my 60-degree reference angles locations. So we had 30-degree reference angles here, the pink, and now we've got 60-degree reference angles here. All right, so all that leaves us with is the ones in between there. Right in the middle of each quadrant, we've got our 40-degree, excuse me, not 40, our 45-degree reference angles. And we said our two triangles we were going to use were the good old 45, 45, 90 and the 30, 60, 90. We've already used the 30, 60, 90 as much as we need to. Now we're going to go ahead and use the 45, 45, 90. Let me pick a different color here. In the middle of each quadrant, we have a terminal side that is 45 degrees above, in the case of the two I just drew, or below, in the case of this one and this one, the x-axis. So this is 45 degrees above the x-axis. Notice that this makes almost like a bow tie shape. Sometimes people like to talk about a bow tie. The four locations that have a 45-degree reference angle. Okay, so let's think about that triangle. Okay, so remember that a 45, 45 degree, 45, 45, 90 is also known as a right isosceles because it has two legs that are the same, which is nicely symmetrical. That's why it's right here in the middle of the quadrant each time, is that you go over and up the same amount. So if it's the unit circle that means this distance, the hypotenuse, is 1 unit because that's a radius of this circle. All right, so using this rule, if the hypotenuse is the leg times square root of 2, that means if I'm going backwards, if I'm starting with the hypotenuse, I would divide by square root of 2. So if the hypotenuse is 1 and I divide by square root of 2, usually we need to go ahead and rationalize that, and that's what we do here. And that gives me root 2 over 2. It can be helpful to remember, though, that this number came from this number because there are times you might actually end up needing to flip it, and it's easier to flip it here. All right, so if the hypotenuse is 1, each of these legs is going to be root 2 over 2. So that's what the coordinates, horizontal distance, vertical distance, of this point are going to be. And the same numbers will be for the point that's right in the middle of each of these other quadrants. So that would be negative. The only thing that changes is the sign. Here they're both negative. And here positive, negative. All right, so we have gotten all of our locations that are sort of in the middle of each quadrant. Let's just talk real quick about these points that are on the on the axes. Well, remember again, it's the unit circle. So the radius of this circle is 1 unit. So if I start at 0, 0 and I go over here, I have gone 1 unit to the right and 0 units up and down. If I start here and I go 1 unit up and no units to the left or right, that's 0, 1. This point is negative 1, 0. And this point is 0, negative 1. So that doesn't really have anything to do with the 45, 45, 90, but I thought I'd go ahead and finish that off on this screen. So let's go back and fill in all these values on 1 unit circle. Okay, so I'm going to stick with my same colors, and going back, these are all of the locations where my terminal side of my angle, is 30 degrees above or below the x-axis. So that would be at 30 degrees. And over here, this is 180. So 30 degrees above that would be at 150. 30 degrees below that, because we've turned less than 180 if we're in this quadrant, right? This is the first quadrant. This is 0 to 90, 90 to 180. So that's why I subtracted 30 from 180 to get 150. If we have already gotten to 180 and we keep turning 30 beyond that, that's 180 plus 30. And then you go all the way around the circle. You're almost to 360, but not quite. We're 30 degrees less than 360. That's 330. So those are my locations. And I just want to remind you that what I've got going on here is a 30, 60, 90 triangle. Here's the 30. Here's the 60. This is the longer leg. Okay? So that to me, makes it easier to remember that the square root of 3 over 2 comes first, because square root of 3 is bigger than 1. So this is the larger is the horizontal distance, and then the smaller is the vertical distance. All right, and we can go ahead and fill in the other values that have that same 30-degree reference angle. Now let's go ahead and do the 60s. We used orange for those. So those are here, and here, and here, and here, and these are all 60 degrees above or below the x-axis in their quadrant. In the first quadrant, 60 degrees above the x-axis is 60 degrees from 0, so that's 60 degrees. So let's write that right here. Here, 60 degrees above the x-axis. Remember, this is 180. Let's write that out here. This is 180 degrees, halfway around the circle. 60 degrees above 180 means I haven't gotten to 180 yet. So 180 minus 60 is 120. Then once I've passed, I'm rotating from here, I've passed 180 and I've gone 60 more than that. 180 plus 60 is 240. And then I keep rotating and I'm going for 360. That's all the way around, but I haven't gotten there yet, and I am 60 degrees less than that. So that would be 300 degrees. So those are my locations that all have the same 30, 60, 90 triangle, but it's turned a different way. It's up on its end where the short part is down here on the x-axis. Okay, and again, remember, if this is a 1, this would always be a 1/2. The short leg would be 1/2, and the long leg would be square root of 3 over 2. So the x value, the x coordinate here, is going to be the smaller number, 1/2, and the y coordinate is going to be the larger number, square root of 3 over 2. So it's kind of flip-flop from this. So this is 1/2 root 3 over 2. They're just traded. And the same thing will happen over here, and down here, and down here. Same coordinates, different signs. And voila! Now we're going to fill in those guys in the middle, the ones that split each quadrant in half. Remember that a whole quadrant is 90 degrees. So half of that is 45 degrees. So here we have the terminal sides that have a 45 or make a 45 degree reference angle with the x-axis for their quadrant, on their quadrant. So this is 45 degrees above 0. And then I'm still turning, and over here I haven't gotten to 180 yet. So I'm 45 degrees less than 180, which is 135. Then I hit 180 and I go 45 degrees beyond that. That's 225. And I'm almost all the way around, so I'm almost to 360 here, but I haven't quite gotten there yet. So 45 less than 360 is 315. So those are my locations that have a 45 degree reference angle. And remember, it's nicely symmetric. It's like a right isosceles triangle. The two coordinates, both the x and the y, have the same numerical value because I've got that 45, 45, 90. Sorry, it's kind of wobbly there. The hypotenuse is 1, so I divide that by square root of 2, and then I rationalize, and both of them will be the same, root 2 over 2. And that will be the same for all of these with different signs. Now we are really close to being done. All I want to do still is fill in my axes values here. This 1 to the right, 1 up, 1 to the left, and 1 down. Now, what else is there to do in the unit circle? Well, for one thing, very often instead of using degrees, we do this in terms of radians. So let's just talk real quick about the radians here. I have made another video that talks about how to go back and forth between radians and how to divide up this circle into radians that I think will be helpful to you if you struggle with that. But for right now, let's just go ahead and fill them in. This would be pi over 6, pi over 4, pi over 3. It's the same location. Pi over 6 is the same location as 30 degrees, and so on. This is pi over 2. It's kind of crunched for space here, so let me just do my best to put it where you can tell what I'm talking about. And this is pi. 1 pi is halfway around the circle. Remember that radians are based on distance around the circle, just like circumference, meaning in terms of the radius. So circumference is 2 pi times the radius. That means all the way around is 2 pi radians. So halfway around is only 1 pi radian. That's why this is pi. So those are kind of crammed in there, but there they are. All your radian measures with the degree measures. And the last thing I want to point out to you here is that it just so happens that, and this is the beauty of all of it, what makes it easy for us to use the unit circle with all these angles is the fact that the coordinates work such that the first coordinate is the cosine of my angle, and the second coordinate is the sine of my angle. Let's revisit one of those triangles to see why. Okay, here's the one for 60 degrees. It's my 30, 60, 90 triangle. The 30 is here. This is the 60. When we say a 60 right here, we're always talking about the 60 being the angle closest to the origin, to the center of our unit circle here. Okay, so cosine of 60, this is my theta. Cosine is adjacent over hypotenuse. What's the hypotenuse here? It's 1. So if I'm dividing by 1, adjacent over hypotenuse just becomes adjacent. So the cosine is just the horizontal component, or the x value. And the sine is opposite over hypotenuse. But if that means opposite over 1, then the sine is just the opposite, or the vertical component, or y value. So that's why I can look at this and say, oh, for 60 degrees, the cosine of 60 is 1/2, and the sine of 60 is square root of 3 over 2. And I could do the same thing if I'm using radians. I could say, you want the cosine of 2 pi over 3? Well, that's negative 1/2. You want to know the sine of 7 pi over 6? That's negative 1/2. You want to know the cosine of pi? Cosine comes first. It's negative 1. And it works that way for all of these. And that is the beauty of the unit circle. And we can use that to find tangent values, cotangent values, cosecant values, secant values, all kinds of different things. Hope this has helped. Subscribe, come back, look for more videos. Feel free to tell me videos you want me to make, and I'll see you next time.